Hi everybody, today we're going to talk about radians, what they are, how to use them, how to switch from degrees to radians. So before we do the arithmetic or the math behind it, I wanted to show you what a radian actually is. So if we're going to start, we're going to start with any length segment, and we're going to spin it around and draw a circle. So now we have a circle, so that's the radius of that circle, or any circle. If we take and kind of copy that and straighten it out, and then bend it on the circle, it's all the same length, and then connect it back to the center, that's 1 radian. Now if we kind of copy and paste that 1 radian, you can see how big it is. There's 2, there's 3, and we need just a little bit more. So it's like 0.14, so that's 3.14 radians. If we double that, and kind of flip this over and make the bottom half of the circle, all the way around the circle, is 2 pi radians. So a radian is kind of a large measure. Much bigger than a degree. So you can do it with any circles. Here it is again, circle. They straighten it out, kind of flip it towards the edge of the circle, bend it, so it makes an arc. We're going to talk about that today too, arc length. Connect it back to the center of the circle. That's 1 radian. That's way bigger than 1 degree. And then if we copy and paste it, 2 radians, 3 radians, and it takes 3.14 or pi radians to make half the circle. So then the whole circle is 2 pi radians. So that's kind of what this is explaining on your paper at the top. So because pi, 1 pi, is the same thing as 180 degrees or half a circle, pi and 180 are kind of the numbers that go together. Now we know that 2 pi is the same as 360 degrees, but pi and 180 is just simplified, so the numbers are smaller. So this pi symbol is basically all we're kind of focusing on. Either we have the pi symbol and we want to get rid of it, or we don't have the pi symbol and we want it. That's kind of an easy way to remember it. So to switch from degrees to radians, right? Degrees, there's no pi symbol there. So we're going to take the 30 degrees and multiply it by pi over 180. And that's because pi and 180 are the exact same thing. So it's like multiplying by 1. Now we can reduce this fraction. So when you reduce a fraction, right, this would be 6 down here. When you multiply a fraction, you go straight across the top, straight across the bottom. You can put this in your calculator, but you cannot put the pi symbol in your calculator because the calculator treats the pi symbol like the number, 3.14. We are treating the pi symbol more like a variable or something that we're not going to change. We're going to just leave it as the pi symbol. So again, if we want this in radians, we want the pi on top. So the pi goes on top, which means the 180 goes on the bottom. You can reduce these fractions. And we just get straight, remember when you multiply, go straight across the top, straight across the bottom. So 145 degrees is pi over 4 radians. A radian does not have a symbol, so please do not put your own little symbol next to it. You don't need to do this. You don't need to do anything. In fact, just leave it blank. For degrees, though, you're going to need to put the degree symbol on there so we know that it's degrees. So 120, I just put that over 1 because it's a fraction. We're trying to put this in radians, so it's pi over 180. 60 goes into both of these numbers twice and 3 times. Of course, straight across the top is 2 pi, and straight across the bottom is 3. So that's how many radians 120 degrees is. Now you can pause this video and try these next 3 yourself, and then come back and check. For those of you not going to pause it, let's do them. So we have 360 degrees over 1. And again, we want to put the pi over 180. We can reduce this to 1 and this to 2. So this is just 2 pi. Now the idea is that you know that, and you wouldn't need to calculate it, right? All the way around is 2 pi, 360 degrees. But you have the arithmetic to fall back on. So again, pi goes on top, 180 goes on the bottom. 90 goes into these two twice, 3 times. This is 3 pi over 2. That's different than 2 pi over 3. 85 degrees. A little bit harder to reduce. So if you don't want to put this, you can just multiply straight across the top and straight across the bottom. And then when you put this in the calculator, you can do 85 divided by 180, and then hit enter, and then we go to math, and then hit enter, enter, because we want it to switch to a fraction. Now, if you do it that way, you take care of the pi symbol yourself, and you have to put the pi symbol back in the numerator. This would be 17 pi over 36. Now, to switch to degrees, again, remember it's about the pi symbol. So here we have the pi symbol, but we don't want it. So you put the pi symbol in the denominator. Well, you can't leave the numerator blank, so you put the 180 up there. Now the pi symbol is gone. And this is more of an arithmetic problem. Your calculator will do 180 divided by 4, 45 degrees. And again, degree symbol, please, on your degree measures. 8 pi over 3, want the pi in the denominator, the 180 on the top. Pi's are gone. Multiply straight across the top. So 8 times 180 divided by 3, or reduce the fraction yourself. That's up to you. You get 480 degrees. 11 pi over 4. Again, pi, we're trying to get rid of it. Put the 180 on top. So you can do 11 times 180 divided by 4. It's 495 degrees. So again, if you want to try these yourself, you can go ahead and pause this, or we'll just do them right now. So 7 pi over 4, trying to get rid of the pi, and then the 180 goes on top. Again, reduce it if you want to, or put it in the calculator. You get 315 degrees. 2 pi, we know what this is. We just did it. It's 360 degrees. Again, the idea is that you don't have to calculate everything. You should know one of them. Pi is 180, 2 pi is 360. That's kind of the easiest ones. Pi over 2, getting rid of the pi. Again, you should not have the pi symbol for degrees. 180 divided by 2 is, of course, 90 degrees. So I gave you that little GIF to describe what a radian is. But again, here you have 1 radian, right? So if you take the radius, remember we straightened it out, and then they kind of bent it to make this right on the circle, and then put it back to the center. So that's 1 radian. So you can tell that 1 radian is much larger than 1 degree, because that's probably more than 45 degrees even. So there's a lot of degrees inside 1 radian. Now we're going to talk about the parts of a circle. You have your radius. That's how we drew the radian. So the radius is from the center of the circle to the edge of the circle. That's your radius. And that's usually the letter R is used for radius. Then if we talked about how, we took that radius and we straightened it out, this piece out here, if we were to cut this right off of the circle, right now it's bent. Well, if we straighten that out, make it into a segment, like let's say call this AB. So now this is segment AB, and if we straighten it out, this is arc length. Now you know from geometry, your arc can have, let's say if this is 60 degrees, and this is 60 degrees. So we can measure the arc in degrees. But that's like taking off the circle and keeping it rounded. But we want to take it off the circle and sort of smush it down and make it flat, make it like a straight line. So arc length. The symbol for arc length, as you can see, is the letter S. All right, so that's going to mean arc length. And we're going to do 2 pi r. 2 pi r is the circumference. Right, circumference is 2 times pi times the radius. Area is pi times the radius squared. Both have pi in them due to the fact that, for the circle. And then, of course, we're going to multiply this by the angle, whatever your angle is. If you don't like the theta, that's the symbol that we use for angle, over 360. So this is how you do it when it's in degrees. If your angle is in radians, you'll have to switch it back to degrees in order to do this. So because we're going to be have all these fractions, and then we have pi, which is a decimal, we will most likely have lots of decimals here. The directions don't really say what to do, so we are going to round to the nearest hundredth, or 2 decimal places, because generally we think of pi as being 3.14, which is 2 decimal places. There is a pi key on your calculator. Sometimes using this pi key gives you a different answer than someone who uses 3.14. The pi key on the calculator is located, if you look at the kind of the right-hand side, the far right column, you have the clear button. And then underneath the clear button, you have the power button, right, this guy. And then above that is your pi symbol. So you have to do second, and then that button right there. And that'll get you pi. So if you don't want to put in the 3.14 every time, just use second pi. It'll show up like pi right on your screen too, like the symbol. So you'll know that you've done it correctly when you see that. So we have a person sitting from the center of a rotating restaurant. Just randomly, we got a person in a restaurant. Okay. So we're going to find how far this person, this diner, sitting in this restaurant would travel after rotating 60 degrees. So if we kind of think about what's happening here. From the center, the person sitting there, here's my person, and they are 12 feet away. And we want to figure out, well, how far did they travel after rotating 60 degrees? Well, you don't want to say, oh, I rotated 60 degrees. Like, that doesn't even make any sense. So we want a straight line measurement. Oh, he went 15 feet, or however far this person happened to go. So this is kind of why we have arc length, what we would use it for. I know it's not very common you're in a rotating restaurant, but in case you are, you could calculate your straight line distance. So we're going to use arc length equals 2 times pi. Our radius is 12. You can put that over 1 if you want. And then it says right here the angle, of course, is 60 over 360. You can put that right into the calculator. You do the straight across the top and then hit divided by 360. We're going to 2 decimal places. It's 12.57 feet. Please be sure to put the units on there. And please be sure to check yourself on your calculator, because if you're just going to type it in the calculator and write down what you get, you want to make sure you're typing it in there right. So for 38 feet, obviously, he's further away, so probably has traveled a little bit further as well. So the arc length is equal to 2 pi times the radius, which is 38. I'll put that over 1. And then the angle, which is 60, goes over 360, because it's like, well, what part of 360 this person really travel? You could multiply straight across the top and then reduce it later. This works into 4,560 pi over 360. If that's easier for you to not put the pi in right away. There's so many ways to put this in the calculator. Put it all in straight away. Do it in parts. But we're going to 2 decimal places, so this is 39.79 feet. And this last little bit, what happens if you're not given the angle in degrees? So let's say the person eating, this diner, is now rotating pi over 4 radians. But they're the same distance away as they were before. So pi over 4 is a different angle than 60, so they're not traveling the same amount, even though they're same spot. So I would first convert pi over 4 to degrees. Of course, we want to get rid of the pi, because we don't have pi when we're dealing with degrees. 180 divided by 4, 45 degrees. So there we have it. So let's figure this out. The arc length is 2 times pi times the radius times 45 over 360. And this would be, it's 3 pi if you put it in the calculator, or 9.42 feet. For 38 feet, the arc length, 2 times pi times the radius, times, we're still using that pi over 4, so we're still using the 45 over 360. And we get 29.85 feet. So try the homework. It's just much like this, switching from degrees to radians, radians, degrees, and a few arc length questions.